Well, if you think about the x's, all we're really talking about is the distance on x and y, so you get that one coordinate, so you can get the vector. So let me show you what that's going to look like. You guys got this? This is kind of small. Can you see that okay back there? All right, cool. So I'm just going to change the slide then. So here's kind of the idea. We have this one vector, and we know that it has its initial point at -1, 3. So here is its initial point, and then its terminal point is at on the positive side. We got 1, 2, 3, 4, 5, 6, 7. So there's the end of it, right? So what we want to do is we want to express it in the terms of I and j. What we're going to have to do is we're going to have to figure out what that length is, what those coordinates kind of are, so that we can actually just move it over and have its initial point on 0, 0. Okay? So what we're going to do is we're going to take this bad boy, in order to express it in forms of ij, is to translate it to there. Okay?
So
but that's how we get the distance for those two coordinates.
Can I and j not be negative?
Yeah. Well, no. The actual letters themselves? No. The coefficients can be negative, but not I and j. I and j are just telling you what you're moving on.
Are you just trying to find, like...
Say that one more time? We're going to right now. So let's do this real quick. Because that's how we write it in forms of I and j. We're not doing polar, I mean not polar, we're not doing rectangular, we're doing it in forms of I and j. Remember, I and j starts at 0, 0, and we know how far to go on I, how far to go on j.
So that's just like all before you translate.
This is how we start, that's how we talk about it. So, what we're going to do,
Okay, well, can I ask you a question?
go for it. Questions are good.
Go back to the drawing. Okay, so, like, if you... Does it have to be going positively? Or can it go, like...
It has to be equivalent.
What does that mean?
It has to be the same. It has to have the same magnitude and the
No,
same
I know,
direction.
but, like, if this... So, like, if your arrow was down here and your point was up here...
Then ours would go the other way as well.
It
It would go down that way, correct.
How did I...
You touched it because I picked up my marker. Okay? So the question was, if this vector were reversed, this was my initial, and that was my endpoint, well then yes, my I and j form would have to be an equivalent, right? Same direction, same magnitude.
I was just trying to figure
Okay?
out if it
So, does that answer your question?
Yeah.
Right now we're after this one. So, to figure out the distance on this, what were we at on x over here? 7?
Yeah.
So what's 7 minus 3? 4? That's my x value, or my I value, right? So I've got 4i. And then what's my distance on the j? I've got 2 minus the -1. That's 3?
Yeah, wait.
Oh, David, I did it backwards. My bad. You're right. I'm so used to doing slow, where you do y's first and then the x's.
Yeah.
So this should be, you're right, it should be 3i plus 4j, correct?
Yes.
So our vector, sorry, did I do that right? There it is. Okay?
I wasn't going to write it down, but I think I should write it down.
I think you should write it down too. Oakley dokley?
No, I'm copying it. Not like...
I don't like it. No, it's just like, it's just use the same symbol as the ring. You mean like here? You could put it if you wanted to. Saying this is my terminal side. You can do that if you want. That's up to you. But you make sure that you do put the arrow so you know which way your vector's going. Because this vector is not equivalent to the other vector, correct? If you want that, you can. Right, it's a race. If you want the point, I don't do the point. You know what? I actually just change it around. Thanks for taking your earbuds out, Greg. Well, you had a question, Sonny? Okay, so adding and subtracting vectors in terms of I and J. For the I part, you will add the x's. Get off your phone. Close your laptop, please. Take these notes.
Did you get 3i4j for the last?
Yes.
What are these 3i4j?
This is just adding and subtracting the vectors in IJ form. So if I have them, if I have some vector, a and b sub 1, a sub 2, b sub 2, if I want to add them, I'm going to add their I values, the coefficient to x's, and I'm going to add the y parts too.
We wrote that down yesterday, right?
It was some version of this, yeah.
I should write it down. Oh no, we were done. You can
We go with this slide? Wait a second over here. One Mississippi? All right, let's try it out. The slides are in your math lab as well. What? Try this out. Use your formulas. We're doing the sum of v plus w. The sum of vector v plus vector w. It's not trig?
Huh?
Because I like it because it's not trig. Actually, kind of is.
It's not even that bad. You can do it fine.
I never knew that was called raspberries.
Oh, my back pump.
Oh, that thingy? That's Loads raspberry.
You know that's like a bad thing to do. So we never like talked about it. Like, please don't do that.
I'm only going Wednesday and Friday.
It's called raspberries.
So I'm
Because that's exactly what I think of when I see people do that. No, not at all. That is probably the last thing I'm thinking of. So, vector v plus vector w should equal. Why do I have two v's? It's a double v. V squared. Double check that, please. You should get 11.9 minus 2j. Okay? Do the difference, please. Do the difference.
That's a really complicated formula for what it is. You're not supposed to put 3 minus 5, that's from right, 3 minus 5 and then positive 3 plus 5. But it'll be written like this. It'll be 3j minus negative 5.
You're writing the answer up there on the side.
Yeah, so you can double check.
Wait, is it 2 plus y 2 minus 5?
What?
Wait, I'm thinking. Wait, so the formula for this is j2 minus j1?
No. A sub 2 minus A sub 1. We're good here?
Yes.
Lexus?
We're great.
How about great? All right, so scalar multiplication. You can also do scalar. You're going to see in the form of k. So k times some vector. Then all you really have to do is multiply each individual piece. So let's say we had, well, can you guys see that okay from back there?
Yeah.
So you, no?
I'm not good at English.
I can't English. Try to make that a little bit bold so you can see it. So you're just going to multiply each of the coefficients by that constant.
Well, but I don't know if this is gonna make sense.
Nope, that doesn't make sense.
What if you're multiplying?
This is a scalar. This is a scalar.
This is just like giving it.
This is making it longer or smaller.
So it's like the equivalent of like giving it.
It's the equivalent of. It's the equivalent of that. Remember that? Where was I at? Here? Here. Nope. Okay. Tara.
Yeah, because it's really small. I just don't want to scratch it. It makes it worse. Because if it's there, I'm going to scratch it. It's falling. It's so itchy. Am I really going to get sick? I don't know. You know that said that? Yeah, it's like Spider Baby.
Yeah, it'll get weird.
Give me Spider.
Why are the laptops open? I don't understand. Are we doing homework right now? Thank you. Where's my dojo? Tara, kick someone for me.
Oh my god, that fits
You have the power. Oh, it's not easy, is it?
No. This is so bad.
Thanks for volunteering. What's A times a vector V?
Hold up, I didn't even write it down yet.
What is it, Yahtzee? What's 8V? I don't know. I can't multiply. Plus what? 80? J?
Oh,
Okay. What's going to be negative 5V? Or negative 5 times the vector?
Can you like simplify?
Negative 35, is it?
yeah.
I minus 50J?
Wait, what?
Why is this so easy?
Oh, it's
Why do you
It's
go?
arithmetic.
Why do you
Yeah,
go
but it's
from the
gonna
past
get
chapter to this?
I know. Chapter 5. I don't remember much of chapter 6.
Because it goes 5, 6.
I'm still trying to.
Well, why do you skip from?
Oh, no. Please do not misunderstand. We're getting down definitions and basic operations. This is like pre-algebra stuff, right?
This is like-
That we are applying to what we're
Like
going
being
to
nice
do.
to a king before you assassinate sharks.
Yeah, this is what my algebra 3 class says all the time. Remember? Or was it in algebra 2 also? You make it look easy and then you drop these hard problems on us. I don't know. Okay, next formula. This one's kind of fun. The zero vector. If you have no vector, you can still write it in the form of I and J. And it should make sense, right? If you have a zero vector, then you have 0I and 0J.
Wow.
This is so difficult.
Is that just for like reference? Like if you're trying to write coordinate, like the I and the J coordinates, it's like if you don't have the J, just write 0J. Or like, do you have to like if J is 0?
Then then you're not going in any direction. You're not going up, you're not going down. There's no vector. Think about a cue ball just sitting on the table. And you don't have a vector until you hit it with the other one, right? That applies some force and it's in some direction. So this is just something standing still, no direction at all. Okay? No, it's just a basic idea. Don't overthink it. If there is 0 vectors, then you can still write it as there's no I, there's no J. Okay?
Wait, I'm just playing.
Okay. Hey, check out these, going back to what Ernie was talking about. Thank you. Look at these properties for vectors.
Oh.
U plus V is the same thing as V plus U. What do we call that? The commutative property. U plus V plus W is the same thing as U plus the sum of V plus W. What is that called? You said it first. Explain to me what associative means.
It means you.
It doesn't mean you move the parenthesis either.
Oh, it means that.
Go for it. I want to hear you. Everyone else think about it.
It's where you can.
Please don't say move the
add
parentheses.
Either ones together, and then you have to add the next one in any order.
Yeah. So why isn't that the commutative property then?
What?
Because there's parentheses.
Because they're the perfect.
That's horrible.
Or the other part.
Say that one more time, nice and loud.
I probably am wrong.
No, absolutely. Go
You have
ahead.
to add the parenthesis part first before you add the other part too.
Yeah, kind of. Here's what the associative property is saying. It is saying that math, my friends,
Sup?
I'm just kidding.
that's recorded on YouTube.
I'm just kidding, guys.
I'll have proof once we go down the principal's office.
No, go to his dad.
No.
Oh, he's closer, isn't he? What this is saying, if you really think about it, is that math is a binary operation. If I give you 3 numbers, 2, 4, 6, add them up for me. No person can just give me an answer. You had to add 2 of them before you added the 3rd one. Our brains are not like i3 processors or something. Okay? We can only add 2 things first, and then we can go back and do something else or do something else. So our minds can only handle 2 things, and that's what this is saying. You can only do 2 things at a time before you can do the next one. It doesn't mean move the parentheses. Okay? Now, if u plus 0 is the same thing as 0 plus u, and you get u, what do we call that? No, that's saying you got 0 u's.
Common sense.
So I took u and I added 0 to it, right? Did it change? Did you say that? Oh, you stole her answer!
I still see it.
Shame on you. Or you, that's a 0, but you can, it's the identity. You added something to a vector without changing it. So it's the identity building. What's this one called? That's the inverse one, right? If you add the opposite, you're going to get 0 to that. If you add the opposite, you're going to get 0. So we've got commutative, associative, the additive, and then the they call it the additive inverse. Okay? You guys remember all those? Sure. Pre-algebra, 7th, 8th grade. Let's take a look at some more of these properties. And I left the names on there for you this time. Take a look at the top one. If I have u and I distribute it, or sorry, this is associative. This is multiplication though. So let me maybe make them a little bit bigger. There we go. So do you guys see this is just the associative again? I'm multiplying c and d before I come back and multiply by u. Here's my distributive property. What's this one right here? That's still the distributive property, except that you're distributing backwards. What's wrong with you guys?
Ask this mumma.
This mumma? Oh!
I'm really crying.
What are they talking about?
I had these letters sticking out, and they were dude, ask this mumuma.
I put it in there.
So let's take care of that one real quick. You child. What's this one right here, guys? 1 times u.
Distributive.
Not distributive. That's distributive up here. These two.
Multiplicative.
No.
Identity. You're not Mika.
Thanks, Mika. That's the identity for.
You can just, yeah.
That's the identity for multiplication. You can multiply by 1, and you don't change anything. This one should be obvious as well. That's a zero product property, right? We use that a lot for polynomials. Finding zeros.
Wait.
Polynomials. I heard someone say that.
Like that. We're just,
No, I heard a kid call it that, and I liked it, so I've used
wait,
it
say it again.
sometimes. Polynomials. I've heard some weird things.
If I heard someone say that, I can
And this is called, I don't think you guys know the name of this one. This is the magnitude property. The magnitude property, right?
What? The absolute value of
If I have some magnitude and I multiply it by some coefficient, I make the magnitude bigger. So it's just C times V.
That's who it was.
And it has to be absolute.
If I had a magnitude of 3 and I multiplied it by a scalar of 5, then that just becomes a magnitude of 15.
How come the C the absolute value?
Because you're just making it 5 times bigger. It could be in the negative direction, but you're just making it 5 times bigger.
Not the absolute value.
Yeah.
So like if it was -5, it's still
Your vector should be negative if it's going to be negative, right? What's inside of this one might be negative,
okay.
but if we're going to make it 5 times bigger, then that would just be positive. Okay. Here's another vocab for you. A unit vector. A unit vector is defined to be a vector whose magnitude is 1.
This is so slow. It's like,
Oh, what the video?
yeah. See, I can't even see that from here.
Here, you want to try these glasses on? Oh, they're missing the legs. You could do this though.
I want to see if I can see it.
Oh. That's my glasses that are good. Okay.
I can actually see it.
Yay, hip hip hooray. Okay.
It's like using a magnifying glass.
So unit vector. You could take any vector and represent it as a unit
I don't
vector.
think I've seen you with that glasses
Do you have dimples? Okay, these are hurting my eyes.
Okay. Here's how you go about it. Write down this. Whoa. Write down this formula. Can we see that okay back there?
Yeah.
Okay. So if you want to do for any non-zero vector, you want to represent it as a unit vector. You'll take that and then divide it by the magnitude.
What is that defined?
A unit vector.
Bad.
Represent a vector as a unit vector. As long as it's a non-zero. Take your earbuds out, please. Thank you, Bonnie. I'm Digger. Just hang on. I had a kid tell me, I got no music on. Come down and bump it. Bien?
Wait, but the
¿Estás bien?
so the top.
I said, are you okay?
Here you go, Munoz. They're hurting my eyes.
Does that just make it
it turns it into a unit vector.
I'm so short with it. Huh?
Okay, ready to try?
I'm at the front.
You try. Find the unit vector in the same direction as the vector 4i minus 3j, then verify that its magnitude is 1. So first thing you want to do is find the magnitude, so that you can divide that by the magnitude.
That's 25 divided by square root of 5. 5,
Yeah, divided by
4,
Look at you, not bringing it here.
minus 3, 5, j. Did it do?
Did it do?
Got it. Got it.
Do.
It did it do?
How long has this lotion been here for?
I did it.
I think I got it in December.
Are you gonna say years?
I see your face on my phone.
Oh no, I can't see.
Oh, okay. I thought you were thinking partially like.
I'm getting contacts today though.
I have some, I don't know if I want to.
That's what I should go do today. Order some contacts.
I don't know
So how long is that break?
Yeah, but then do you have to do this divided by 5? That's what I'm like trying to figure out. I was like, let's not make it 1, but that would make it 1. Unless it does make it 1.
Oh, yeah, it does.
Yeah, that's really
I need to get dimples.
Oh, yes, I think you guys sit on the floor.
No, sorry.
How does it, so like we got a magnitude of 5. How does that make it?
Good.
Does that mean that 4i minus 3j is 5?
So this is 4 and this is 3. Right?
It's right there.
Right now.
It's because I'm on this side.
Right?
The back.
Oh, I got it right.
There's my unit vector.
Basically, all you're doing, find the magnitude.
So these are the directions to my endpoint, correct? So to find the magnitude, I'm going to find the distance of the hypotenuse. Okay, I'm going to find the magnitude of the vector. 4 squared plus 3 squared is going to give me 25. Take the square root of that, you get 5. That's the magnitude. So I'm dividing my vector by the magnitude, which technically is just 5. What's 4 over 5?
Wait, what's the vector?
The top is the vector. It's in that polar, in that ij form, but it's my vector. And then negative 3 over 5 is negative 3 over 5.
Why does B represent 4i minus 3j?
B represents the vector 4 minus 3. Yeah.
Why does it represent 5?
Because it's the magnitude.
Why does it represent 5?
Yeah.
No. This is V. This is the magnitude of V. Right? Okay. How can I verify that this really is a unit vector?
Plug in something.
Plug in something?
That's what I was trying to figure out. 'Cause I'm
How?
like, how does that make
That's
it
what I was
1?
just asking. You're asking it?
Change it back.
Okay, wait.
I could change it back, or I can just use Pythagoreans again, right? Because here's my vector, correct?
Yeah.
How can I check my magnitude there then? Blah, 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 what did I do?
What is this?
Okay. That this is supposed to be a unit vector. So here's what I'm going to do.
I thought a unit was.
Correct. So we're going to verify that it's 1. Okay, you ready to verify?
Oh, I see it.
4/5 squared plus negative 3/5 squared should give me
Whatever.
16
16 over 5 and 9 over 5 plus 25 over 25.
25 over 25.
no. What should that equal if it's a unit vector?
One.
Should equal 1, right?
I
25 over 25.
So what's 4 squared?
Yeah.
16 over
5.
plus 9 over 25. What's 16 25ths plus 9 25ths? 25 25ths. Does that equal 1?
Yes.
Unit vector.
It equals I.
Did it jump?
The kid is a Munoz.
Really accurate.
So it's a unit vector, all right.
Alright, wait, did you make that noise?
I did.
That was very accurate.
I watched a lot of Simpsons.
Is that a lot of practice?
No, it just came out one day. I was like, oh, that was cool.
I'm like, wow, sorry, I don't mean to flex you guys. One day. Alright, thank
No, it's not. I have 3 slides. But I don't want to be rude and interrupt people's conversations with my teaching. So I'm going to wait for you. Carry on.
I take that opportunity to shoot.
Oh, yes.
Oh, God, great.
Let V be a non-zero vector if theta is the direction angle measured from the opposite x-axis to the V vector. Then the vector can be expressed in terms of its magnitude and direction angle as the magnitude times the cosine theta of I plus the magnitude sine theta of j. And that should not be surprising to you,
It's
because what do we usually call cosine? The x. And we usually call sine the y.
okay. I'm gonna write this down, but I don't know what it means.
I'll show you. Yeah, you can fix that by sitting up front. My computer? Because people keep on plugging me. Sitting my power supply down there. What I need to do is I need to throw this out.
Getting cardboard, long walk. Oh, yeah. Can you go back real quick?
Go back?
Yeah. They want to graph.
We're doing polar axis.
This graph?
Yeah.
That's crazy. This, bro?
know what I'm doing, so
Ah, look at you.
I'm cold.
Not cold.
What?
Not cold.
What?
That's how it looks.
We'll get gunner this time.
And then you can look cold next.
You're good now, man.
Okay.
He's always been good.
So try this out. Oh, que la pues.
What is that?
What do you need?
Just the, oh wait, oh is that just AI plus B? Okay.
You need the formula?
No, fine.
Yeah.
Is that a little bit better?
I got it. Yeah, sorry.
No, you're good. So I'll make sure you got it. Okay, try that. Let me make this a little bit. You see that okay? I had a friend. He couldn't see, and whenever he was gonna order, he'd go. Anybody do that?
Yeah, well, I split. I have all wrinkles up here.
I think that'd be hella expensive. What if someone
You
I
know,
blame
when
my
you
eyes
yawn,
out.
it's so weird when I yawn and my eyes get so watery, I can see.
Yeah, this yours clear up your vision.
I don't know what to tell you.
What if you're like,
You guys remember the bearings, right? How to do bearings?
yeah, she was Asian.
Cool.
Yeah.
Do it again.
What?
What if your cashier was like Asian?
Is this on the polarized?
So we're traveling north. We're traveling north, 45 degrees east.
Yeah.
Oh, yeah.
That's 45 technically. This is 45. This is be the one we use. A reference. Okay. What's my magnitude here?
16.
16.
Per hour.
What?
Because it says it's blowing at 6
That's not right.
Stop it.
And then
at 60 miles per hour.
And then do it.
But in terms of IJ, it would be what?
And this is like, is this supposed to be like a unit vector?
No.
Wouldn't it?
No, we're just writing them now in terms of sines and cosines, right?
Just got a message from Postmates.
Yeah, I get those all the time.
Someone give me the formula. What was it? It was the magnitude,
Cosine
cosine theta I.
plus the magnitude of sine theta t.
So, what's my magnitude? What's my angle? What's my magnitude?
60. Yeah, 45.
That make us done?
Wait,
No, we're not done.
I know, but like,
What's the cosine of 45?
Square root of 2 over 2.
Radical 2 over 2. I. Well, 60 times J. What is that, 30?
hey, we did this in the home
Wasn't this specific equation?
but it was one of them.
I was looking for all like.
There we go.
I was doing this when I was sitting outside of my biology class. No, like
That's a question about. Yeah, so I got that.
What?
It was just like.
Are they gonna throw imaginary numbers on us ever? Do this?
You should always expect them.
I am expecting them. That's why I'm asking. Because like, how are we gonna tell the difference?